Okay. Is my screen visible? Both? Yes. Anil, is my screen visible?
Yes, yes.
Okay. So in last session, if you see the video or like in live session, if you attended, I have finished till here. Okay. We have stopped in the sea surface. Okay. So for now, just 1 minute. Okay. Okay. Yeah. So what we are doing today? So now we have created the sea surface in last session, session number 6. Okay. So A surface we have created, then B surface, and this is C surface. Okay. So C surface still here we have completed. So now we'll proceed. Okay. So if I'll hide this A surface and B surface. Okay. So this C surface we have joined. Oh, this is a sweep. We have created a sweep. Okay. With reference surface 90 degree. Okay. This was our last thing. Okay. So if I on this, so this is my tooling direction. If I make it normal, you can see complete sea surface is visible to me. This complete sea surface is visible to me. Okay. So no additional draft required here. Okay. Zero draft is fine because core and cavity will design like this. Okay. So core and cavity will be like this, right? This is our square. So core and cavity will move in which direction? So let's say this is our tooling direction. So core and cavity will move in this direction, right? So this is our cavity side and this is our core side, right? So something like this, okay? And from here, second, okay? And like this, its mold will design, right? So this core side will move upside. For that, this is a flat side. This is for tooling direction. Our C surface is perfectly flat, 0 degree. Okay, 0 degree means 90 degree we have created. So if I'm checking the draft analysis with C surface in part design, to draft analysis, then we'll do the draft analysis for C surface only. Okay, because A and B is clear. So if I'm running this draft direction for C surface, this is my C surface sweep. Okay, if I reverse this, see complete C surface is green. Complete sea surface is green, clearing in the tooling direction. Okay. The problem was here, we discussed in last session also. This is the problem. This surface is step, here step. So if I'm watching from this tooling direction, this surface is not clear. Okay. If I click OK, if I normal this tooling direction now, you can see this is undercut because that surface is not visible to me, right? Undercut means it is not clearing in our tooling direction. Okay, so it is not clearing in your tooling direction. That surface is undercut. Okay, that's why it is showing red. See, so what we can do here? Here we have to create a surface with our draft direction in angle. Okay, because this C surface we can make a changes. In C surface and B surface we can make changes according to us, right? A surface we cannot change, right? So this is the problem. So this type of problem we have to check. Okay, so how can we tackle this problem? Okay, so this surface we have to make according to our tooling direction. Okay, this is the tooling direction because rest of the all surfaces, C surface is visible to us. Okay, just 1 minute. Okay, so now what I'll do to remove this undercut, this surface is in undercut. Okay, Rest of the all things are okay. So what I'll do first, I'll remove this surface. I'll remove this surface. So for remove, we'll define the C surface here. I'll go into the generative shape design again. Okay, join. You can take a join and select this surface and remove sub element to remove this. This surface I want to remove. You can remove in a sub element to remove. Click OK. Okay, so that patch is removed. And now that patch will create according to the tooling direction. Okay. For that, what I'll do, I'll take a sweep command, and in second this session line, there is a command with drop direction. Drop direction means tooling direction. Okay. So guide curve is this drop direction is our tooling direction. And then we have to choose the drop direction. Now this is 0 degree. So we want 3-degree drop, right? We want to clear this part into 3-degree. So I'll put the 3-degree drop preview. Okay, so here 4 arrows are coming. So what I'll do, first put more value so we can get the arrows. So which arrow I want to select? This arrow. Okay, this side, because this is the direction is visible from tooling direction, right? If I'm creating the surface like this, is this point to this point, then only from tooling direction normal, this surface will be visible to me, right? So that's why how much now, once arrow will selected, we'll put the value that is 3-degree. Okay, preview. Okay. Okay, now we'll check that surface with the, is it clearing with the, now we'll check the surface if it is clearing in the our tooling direction. Okay, if I see, click and make a normal, see if that face is visible, yes. Now you can see this surface is visible to me. So it is, now it can clear in the tooling direction. Okay, so that's why we have given the we have made the surface in the drop direction. Okay, so I'll go to the part design again and I'll check that surface. So again, we'll run this thing and I'll match this to this. Reset. Again, we'll reset this block. Now I'll check my sweep surface. Okay, now you can see this is clearing. Okay, so what I did, again I'll show, because previously what was the problem? Okay, this was the problem. This is perfectly 90-degree surface, right? So whenever we are doing the normal to the tooling direction, rest of all is green. Okay, and this is not visible surface, it is going in the undercut. Okay, so that's why we have created the surface outside like this. So it can be visible by tooling direction. It can easily remove from the core. Okay, so now we have created the surface with this according to tooling direction. Now if I make a normal, see, now this surface is visible to me. Okay, so this surface is can clear in the our core. Okay, yes, any doubt till here? This is not understood, anyone? Why I did a drop direction? Yes, Balraj, Anil, Viraj, any doubt in this surface?
No.
Clear, Balraj?
Yes, sir. Yes, sir. Clear, sir.
Okay. Okay, so you have to check, is it undercut, and then according to drop direction or tooling direction, we have to give the make the surface. Okay. So now next thing is I'll give the okay. So this is fine. This can clear, no problem. We'll see later. We have to add here surface more. Okay, so we'll see later how to do that. Next is this thing. So here also the same problem will appear. generative shift. Okay. So if I want to close this, simply what I am doing, I'm taking the this thing blend. I'll select this area, click OK. Okay, so, support is A surface, and again I'll select click multi extract B surface edge, click OK, and support is this second surface. Okay, click OK. Sorry, it is you have to change the tangency. Okay, tangency will be point, flat surface. Okay, now again this surface we have made perfectly 90 degrees. Same problem will happen if I am looking this surface with the normal. See, that surface is not visible to me. So this surface also will go into the undercut. Okay, it is not visible to me, right? So how can I create? So this thing also will not do the blend here. Okay, so I'll run again sweep with drop direction. Okay, guide curve will be create multiple extract. This is click OK. Drop direction is this. Okay, and which arrow I have to choose? So I'll put the value, more value here. So for clarification, see here are 4 arrows. Okay, so which arrow I have to choose, this or this? Okay, that also will see. Okay, so I'll select this. For one hole, I'll select this arrow, and for one hole, I'll select this arrow. Okay, so we'll see the difference. And white will take a more 5 mm. Okay. Now, if I see this face normal, if I hide this, first we have to trim that so we can able to see. Okay, so we'll try for both different arrows. Okay, so that we'll see. So again, what I'll do, again sweep, guide curve, multiple extract. Okay, this is okay, and drop direction is tooling direction. And this side we selected, I'll select now this. Okay, both are different. So now what I'll do, we'll run the draft analysis. Part design. Okay, and which to sweep? This one sweep and this one. See, which is in undercut? This is clearing and this is undercut. Okay, so which direction we have to choose? This direction, outside. Okay, then it will clear. And whenever I'm selecting the A surface, it will match to the A surface. It has to be joined. Okay, we have not joined the surface. Okay, so you have to choose the arrow which side you are going to clear, like clear these things. Okay, we'll split so you will get more clarification. Split the surfaces. So I'll take an intersection here. This surface and this surface intersection, and intersection will split. Split this surface from intersection and this B surface from intersection. Okay, and I'll hide this. Okay, now if I make the normal, see this C surface is visible to me. Okay, so this can remove in the mold core, right? But this side it is not visible. If I trim this, it is again hiding, right? So this thing also we have to change the direction. Okay, direction will be outside. Okay, not 15 degree, it will be 3 degree. Okay, same thing. And we have to again split this. So split this surface with B surface and B surface with C surface. Okay, normal. Okay, it is visible. This also, I can see which is this sweep. I don't know, na. I have to find. So here are the one command quick select. You can select on the quick and select this. It will show you which is the sweep. So this is sweep 4. So you can right click and center graph. Okay, and you can double click, and this is 3 degree. Okay, not 15 degree. We checked for only 15 degree to choose the arrow. Okay, so now see it is updated. Why? Because I have extended this surface. So keep extra surface. Okay, so automatically you can update your surface. Otherwise, if the material will short, if I not extrapolated, so that time it will create a problem. Okay, so it will get a update. Okay, this is fine. This is visible. Now this is the thing. Okay, here also same thing we have to do. What thing we have to do? Create this thing. Click OK. Okay, and what we'll do? Sweep. With draft direction. Guide curve is this. Draft direction is this. Okay. For arrow selection, I'll put more value. Okay. So this which direction we have to choose? Or this or this direction. Not this is not visible. This direction. Okay. According to that, you can choose your directions. Okay. Here some surface is placed, so intersection will not come. So what I'll do? We'll extrapolate this surface 1 mm. Okay. Not 1 mm, more than that will extrapolate. So okay. Okay. Now again, I'll intersect these two surfaces, this surface and this C surface. Okay, and split this. This is from intersection. This is okay. And it's 15 degree, not 15. This is 3 degree. Okay, keep in mind. So now it is updated automatically. Okay. So like this, automatically your surface should update. Okay. Now surfaces are ready. This thing is pending here. So here also we'll intersect this first. Intersection, this and this. Oh, here some surface is placed, so I'll extrapolate this first. Extrapolate. Okay, your surfacing you have to focus more because surfacing we required more here. Okay, and now I'll go for trimming, intersection this and this. Keep only one, so I'll check this and split this to this. Split this to this. Okay, right. And here also some intersection, so we'll take an intersection. Okay, split this from this, split this from, oh, complete edge will take. So what I'll do here, okay, we'll extract this edge and we'll remove. We'll take a boundary first. No propagation. Okay, and we'll join this both. Or trim also, so it can be one surface. So that's patch I have to run. Okay, and now we'll try split. Reverse direction. Okay, done. This side also extra surface, so that will cut. So here intersection with will be with a surface. Okay, so I think a surface also some more we have to extend here. Intersection, this and this. Split. Okay. Here also same thing we have to repeat. Okay. So this is C surface. Oh, in C surface we did all the work. So modification we have to do in A surface modification. Okay, here we have added. So whatever A surface modification, B surface modification, whatever we have cut, we have to do in B surface. Okay, so that you can define. Okay, so whatever the operations for A surface you can put into the B surface. So currently this is my A surface, let's say, and this is my B surface. This is my C surface. C surface is not joined. So I'll give the color for identification. A surface, sorry, B surface. This is A surface. And this is our C surface. Okay. So this is the complete thing. And this surface also we have to join. So now for now, open in subtree because I'm going to use this thing. So I'm opening it in subtree. Whatever repetitive task you are doing, repetitive command you are going, you can open in subtree. So I'll add this both the things. Okay. And now this is our C surface things. Okay. So I want to join all the things. Look at this thing and this patch, this patch, this patch, and this patch. Okay. So here for joining, you have to opt this option, check connectivity. If you are clicking OK, it will give this connects non-connects result. Okay. So I want C surface in one form join. That's why I am off. I'll opt this option. Okay. For join. So this C surface is now one thing. Okay. So now we'll run the draft analysis. We'll see is it okay or not. Okay. Green, 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 green. Okay. Clearing all the things. Fine. No problem. Now A surface. Okay. So this is B. A surface. Okay. So we'll create a final join now. So in construction element, we'll add new geometric set. That will be final join. Join A plus B plus C. Okay. And we'll join all the three. These three. Define show. Okay. We'll join all these three in the final join. Surfacing, join. Okay, before joining, you can do one thing. Uh, what you can do, you can take the intersection. First, take the intersection of A and C. First, take the intersection of A and C. For double confirmation. Okay, this is A surface, this is C surface. Okay, we'll take an intersection. So where it is, okay, this it will show no problem. Okay, so this is intersection. So this intersection will be our most probably parting line. Not parting line. Parting line will be different because I will discuss that also. Okay. So I'll delete this. Okay. And now we'll join all these things. Final join. Join this 1, 2, and final join is C. Okay. 10 micron we are joining. Okay. Click OK. So this is our final join. So if I run this, okay, so it is not making close body because we already discussed this is the tangent. So here surface is missing. In A surface itself, here also some A surface is missing. So A surface was not good. In last session we have attended, we discussed this. Okay. Okay, no problem. But here we can run the draft analysis and we'll check our part. Okay, so A surface was not good, but we proceed that surface because if A surface they are giving us new, we can do the style replacement later. Okay. So purpose is our part is clearing or not? Just a minute. Okay, reverse that. See what is happening. Here, this surface modification we discussed in the last session. If we are not, if we not did, okay. So here the problem is this. Our this thing, our parting line will come here, and this is our A surface, and this is also our A surface. Here also will be the same problem, right? Okay, so parting line is coming here. Why? The direction of our sweep that is wrong now. Okay, for that, this is part is okay now. Now your part is clearing. Okay, your part is A surface is clearing, your C surface is clearing. Okay, all the things are done. But sometimes what happen? We are not recommending that your parting line will be at A side. Okay, so this if I apply the fillet here for this edge, okay, so my parting line will become middle of this. Okay, here also my parting line will come here, middle of this. And here also my parting line will come where? This edge. So that is not recommended. Okay, so we'll change the sweep direction. No problem. Reverse direction will take. So our parting line will come inside of B surface. Okay, rest of okay, all the things. Okay, so how we'll change it? So quick select will do generative shape design. Quick select. That's why you have to run your this thing. What? Draft direction, draft analysis. Okay, draft analysis is most important. Quick select this side. So this is sweep for center graph. Okay, you got this. Double click and change the direction. So direction will be change. We'll check this. So see This is the problem. Now this surface is not extra. That's why it is creating a problem. No problem. We'll do Z. So that's why we have to keep an extra surface because automatically it will not update now. No problem. We'll change the sweep. This direction we have to take. Why we are changing? Because of the this direction. We are parting line only. Okay, parting line we are not keeping at the A side. We are keeping at the B side because this is a visible surface, right? So parting line will be visible from this edge. That's why. So that's why we have to change. They understood what I am doing. Yes, Valraj, Anil, Viraj. Why I am changing the direction? Understood?
Yes, sir.
Yes, sir. To clear
Yes.
that.
Yeah.
Yeah, potting line.
Okay. Yeah. So for parting line, I want parting line at B side. That's why. Rest is okay. Okay. So how can we change? So what we'll do? This surface we want to extrapolate. No problem. I'll hide this. If you are new in surfacing, okay, you don't you don't have experience and like that. So what first we have to do? See, you can do one thing. You can select the join command and select this complete portion and sub element to remove. You can remove this. No problem. Directly. Okay. So that patch will remove. Okay. This patch also we want to remove. If you want to edit these commands, if you know, and this patch also, all patches we have to remove in join. Sorry, this is not select. Okay, these patches we are removing. Okay, so all patches are removed. Now we'll run again. Draft an sweep command. So sweep command will check if it is happening. Okay, curve with this. So right click, create multiple extract, this thing, keep okay. Draft direction is Z direction. Okay, now we'll select this thing. Okay. And we'll extrapolate this inside for from point continuity and keep extra dimension because in future if you want to change the direction now, so that time it will automatically update. Okay, so I'll keep 5 mm. Okay, keep extra dimension so it can automatically update. Okay, and I'll take this thing intersection, this thing and this thing. Keep only one sub element, that is this. Okay, and we'll do the split this from this and split from this. Okay, and now we'll check with this first, is it okay or not? Okay, so I'll join this with this all surfaces. System join. It's complete and this complete. Okay, we'll check that now first. Okay, so second you can directly do that. Okay, so first check that because if you're doing all this and again it will be wrong, then we have to change. That's why we'll check first, is it direction is okay or not. See, clear? Now your parting line will be which side? B side. See, this is your parting line. Okay, now A side. So that's why we have changed this direction. Okay, same thing you have to do here. Okay, I'm not doing same thing you have to do here and same thing you have to do here. Okay, see, draft direction is now parting line will be here for this part. This is your parting line. Okay, so always try to keep your parting line at B side. Okay, if I'm watching this surface from A side, okay, so my parting line will be not visible, right? This is at that B side edge. Okay, but here if I'm tilting my part here, okay, so this is visible side. This is my parting line. This is not recommended, and this is also going upside, right? And A side. So try to avoid the parting line at A side. Okay, and this we changed in the last session. You can change first in the A surface. For this, I think we changed. So we have done some modification. Last session recording, you can watch how I did this. And this is parting line. Okay, so second and this you can do, right? Both. You can change. Yes. Anil, Balraj, you can change, right? What I did here, same thing you have to do.
Yeah, sir.
Okay. Okay. Okay, so parting line, you can click OK. You can keep these things okay, and you can extract the surfaces. Sorry, extract the edges. What edges? Here, add new geometric set. Parting line. Sorry, parting line is added already. Define this. And extract the edges, okay? Where two colors are differentiating. Go here. And here, extract. Okay? And then select this edge. Add in tangent continuity. Okay, extract these edges. So for a while, we'll hide this draft analysis. Okay, and these edges you can extract. First, you have to make the part solid. So our A surface is not good. So that A surface modification will do. How to do? I'll teach that also. But A surface modification is not on our scope. If the customer is suggesting that you can do, then only we can go for. Okay. Then this edge will be our. Okay, like this upper edge you can extract. Sorry. Remove. This upper edge also you can extract after the modification. And this upper edge. Okay. So this will be your parting line. Click OK. Keep all sub element. And okay, you can do here change to this. And if I on this graph analysis, okay, so this will be your parting line. This is your tooling direction. This is your parting line. For this, you have to make a changes. Okay, so A side, B side, our parting line will be at B side. Clear till here? Any doubt? Anybody? Okay, you can complete this part now. Tooling direction and parting line. Yes, Balraj?
Yes, sir.
Last session I have sent you 2 CAD tests also. I think nobody sent me the PPT. Okay, so there also you have to use the draft direction. I think it is open admin. Okay, this was one part. Okay, so I'll give you the idea how to do that. You can do the same thing. Simple surfaces. Okay, little complicated, but if you try this, you can solve this. Okay. So here what you have to do. I'm not making the tree structure. You can make the proper tree structure, analyze this surface. First disassemble, join in a 10 micron, then offset. Okay, I'm directly inserting the geometric set here, and let's say this is. So what you have to do, you have to disassemble this surface, right? Click this, click OK, hide this, okay. And here, this is, let's say, class A surface. So you have to join this class A surface in distance propagation, and this will be 1 micron. Okay. This is, let's say, class A, you can name it. Then another geometric set, class B, you can offset this surface. Okay, reverse direction 2.5, I think. So you can give the color for identification. I'm not making tree structure, you can make it, okay, here, not this color. Which color you can keep? Let's say this, okay. And then main is C surface. First, we have to create the tooling direction, right? So tooling direction, we have not created. So I'll insert new geometric set for tooling direction. Tooling direction, how we are deciding? Make a geometric view. So in this direction, it is clearing more surface, covering more surface. Okay, so we can make the direction, okay, parallel to Z. Okay, Z direction, more surface is visible, right? So if I keep this like this, more surface is visible. Okay, so I'll insert 1 point on surface, on this surface, make a 0 mm. Okay, and then isolate this point because we don't want dependency on our part. Then tooling direction, create a tooling direction, point and direction. Point is this, and tooling direction we select as a Z. Sorry, not Z, Y. Okay. So this is, let's say, tooling direction. We run the draft analysis now. Part design, draft analysis. Okay, we'll keep this thing here. Okay, and A surface join. Okay, clearing in 3 degrees, no problem. Okay, so we can offset this. We've already offsetted. Now, main thing is C surface. So if this is my tooling direction, if I make it normal, see, which surfaces are perpendicular to this tooling line? You can say, if I'm going for C surface making, this is perpendicular and this is perpendicular. So these two, from this edge to this edge, this patch will be come into the draft direction. Normal, whenever you are making the sweep, make a sweep with the draft direction, because this is perpendicular to your tooling direction, right? This is visible completely. So this is come in A surface. So don't think about this first. So this is will be your draft direction, and rest of the things will make a 90 degree, no problem. Because if I'm keeping this is my this is my die, this is my core, and this is my cavity, right? So for tooling direction, these faces are parallel. This face is parallel, but this face is perpendicular. Okay, so what you have to do here? For C surface, I'll insert new geometric set. Okay, and C, I'll make it again normal, which is visible point here. Till this edge, it is not visible, right? So from this edge, this is completely visible. So we'll think another thing here, how to solve. Okay, that is one thing. But from this edge to this edge, okay, I think this edge, this point, it will perpendicular, our C surface will be perpendicular to our tooling direction. Okay, so what I'll do simply, I'll go into the generative shape design, and we'll take a sweep, not sweep, we'll take a boundary first. Boundary command, A surface, a limit I'll set, okay, from this point to to this point also we can take corner. First, don't go for corner. First, create a flat surface. Okay, corner there will be a you can create. So I'll take this till this point for okay, and then now I'll take the sweep command. Okay, guide curve is this, and draft direction is this. Okay, see it is showing this flat. So I'll put the 0 degree. Okay, 0 degree is fine. Now I want to add a 3 degree, right? So first I'll take a 15 degree for identification. Which side you want to add? This side will take a 3 degree. Okay. Why this side? Because if I'm taking this side edge, so it will be visible when our surface will be visible, right? When we are making the normal. That's why I've selected inside arrow. Okay. Click OK. Now we'll check the this surface is clearing or not. Part design. Where it is from. This is okay. See it is clearing in 3D. Okay, so this is with draft direction. Now this surface don't need draft direction because this is parallel to face because it is going to sit like this, right? So this cavity will here, core will move here. So this flat is also fine. Okay, so this flat from this edge, it is not perpendicular. It is see it is at 0 degree. But here we need a draft direction. Understood what I'm saying? Yes. Any doubt in this concept? Understood, Anil, Balraj, Viraj? Why I
Yes,
did
sir.
the drop direction? Okay.
Yes,
Yes, sir.
Okay. So now here you can make your thing. What you can make a blend or like that. Till here, till where? That is also the question. So you can make it normal. Okay, I will do the this side so you'll understand. Okay, so okay, from this point to this point, something we have created. So now if I'm making this normal, okay. So this surface is visible. So till this bottom point means till this bottom point to from here, okay, totally connected. So that is completely flat. So that we can make in our regular direction also. So we can take a what I'll do. I'll take a boundary command. Select this edge. Okay, limit will be till this also fine. This point, or we'll leave the corners, this side and corner will create after that. Okay, reverse direction. Not this, reverse direction. Okay, click OK. Now I can make a normal sweep also here. Normal sweep means sweep with reference surface also fine. Or with draft direction if you want to make guide curve. Draft direction is this. Okay, and 90 degree you have to make here. Right, 90 degree surface. So it can match to your B side. Preview. Okay. 90 degree surface. I am not adding any draft here, only 90 degree. Fine. So this side is complete. Now you can think about this thing. You can think about this thing. How can you think? So here can make a blend also. This and this. Okay. And this. And here we'll do the multi-section. Okay. And now all join all these things. This, and dispatch and dispatch. Some connects result. See here, the gap is bigger, right? See, it is not proper thing. Okay, so this blend will delete. And this blend is also not working. We'll delete this. Okay, so here you can try for this thing. What? Multi-section. So what I'll do, boundary. Limit is first is this, second is this. Okay, and I'll try for multi-section. This edge, surface, this edge. Okay, surface, right curve will be like this. Okay, now we'll join all this. Okay. Now again we'll check is it clearing all the C surface in draft direction or not. Okay, part design. Okay, clearing. Okay, till here all the things are okay. Now this patch. This is a very important patch. How can we make normal? Generative shape design. Okay, and we'll take again sweep, and then draft direction is okay. This patch first I'll make with the draft direction. Okay, 0 degree. Below, and we want 3 degree, right? Not 0 degree, 3 degree. Okay. Okay, outside arrow we have to select. Okay, but it's not looking coming completely. So what we'll do here, and here also some gap will come. Let it be. The gap is coming, so we'll do that thing. Because the part is like that. This is visible side. This patch is visible completely. So it is going to clear in A surface, means cavity side. Okay, so our parting line will come from this edge. Okay, because we cannot make parting line here. This is our A side, right? So parting line will come from this point. Okay, so we don't have option there. So what we'll do, take a isoparametric curve because I want to cut this surface because there is no use of this surface still from this point. Okay, so we can trim that portion. So isoparametric curve from this, I'll cut it. Split. Okay, write it. Okay, and you can make a blend because this is anyway going to this patch is anyway going to cover in the cavity side, so no need a draft because it is clearing in that Z direction, na? This Y direction directly. So this patch is not need of draft. So we'll directly go for blend. between this patch or this patch, click OK. Okay, how to decide a draft? So you do the more and more practice, then you decide, like, understand how, which draft you have to remove and what not. Okay, so try to practice more things. Here we'll make a this thing. I'll make a this thing because this is a corner, na? So I'll make a multi-section. This edge, and corner will be like this. Okay. And here this gap is coming. So here, see, your parting line will cut here. Okay, your parting line will come from this edge, and from this point, it is splitting. If you want to see what will happen here, what will happen. If I am extending this to 1 mm in curvature, okay, and if I am making a sweep, this edge with 0 degree. Hello? Yes?
So nothing, sir. Sorry.
Okay. With reference surface, and surface will be this. If I am making a 3 mm. Okay, so this step will coming here, na? So you will understand what is the use of this step now. If I am making the trim between this and this, okay, and he will join this all, this surface, this surface, this surface, this surface, this surface, this surface. Sorry. Sorry, again I'll join this. 1, 2, 3, 4, 5, 6, 7, and 8. It's not selected. Selected. Okay. Okay. Now we'll run the draft analysis. We'll see what will happen. Draft analysis. See what is happening here. This patch is in a green and this patch is in a blue color. Why? Understood what is the problem, and you can see this is your parting line. So this will, we have to make a draft here. So but this surface we have to make a draft. But this is the line of your parting line. Okay, so because this surface will clear in the A surface. Okay, cavity side. That's why it is green. Okay, and your parting line will be come from this edge. This edge, this edge, and it is not visible, na? Like if I make this, click OK. And if I make this line normal to curve, see which is the visible side till this edge only visible side, right? And from this point, it will turning into the cavity side, your parting line. Okay, so if you see, you can see the difference. It is dividing the color. Okay, so this is, and this surface also you will come into the green, means A side. It is visible thing. Okay, that's why. So you will practice the more surfaces, you will understand what I am saying. Okay, so here also we have to make the same surface like this. Okay, so this is the parting line. So here you can try the surface. How can you try here surface? What you have to do here, simply define the work-in object. Okay, and here this surface also you can make a line from point to point. Lots of options are there to create a surfaces you can create. And here go into the start generative shape design. Okay. And here sweep you can take with drop direction. Guide curve is this, drop direction is this. Okay, this is the drop direction. First we'll try with the 0.5. How the surface is coming. So it is breaking the A surface. Okay, so here we have to think something because here let's say we are putting 3 mm. So you can see it will cut more A surface. Okay, if I am putting this, we have to increase the A surface in this side. So A surface we cannot make a changes, right? That's if they are saying, okay, you can cut some surface, that is fine. Okay, so this patch I'll show you how to do, but till here to try and save this part in next session I'll solve this, and that first characters also will solve. But today's topic was drop direction. Okay, always make a perpendicular patch with the drop direction. Okay, for C surface, if you are making perpendicular patch, any drop direction is very important. Okay, so that today's part, like first part, you have to complete this CAD test. Till here you can complete and save. Okay, and next session we'll make this patch, because this patch we have to think how to create, because we cannot cut A surface also, and this also we have to match. Simple thing, we will try in the next session. Okay. Yes, still here, anybody having doubt, you can ask me. Yes, Anil, Balraj, Viraj.
Yes, sir. Have to do the
Yes, sir.
practice, sir.
Practice is important, yes. Because whenever you're doing the more 5 parts with the drop direction, then you will understand how to clear in part in a drop direction. That is very important thing.
Yes, sir.
Yes, Balraj, do you have any question?
Yeah, no, sir. It's clear now.
Okay. Yeah. So try this. You can try also. Okay. This is we want to clear in a surface like this. This is we want to clear in a surface. Sorry, cavity side. So that's why think about that and make a patch like this. Okay. So try it. Otherwise, will save this part as it is and we'll continue in the next session. Okay. So first catches also will solve that also you try now. You can think about how can I clear with the drop direction. Okay. Because some student having facing like they're making the surface 90-degree. Now you try your surface, C surface to clear in the drop direction, 3-degree or 93-degree, it will come, whatever. Okay, so 3-degree trying to clear. So it will clear in first CAD test also. Okay, try it, otherwise we'll solve, no problem. Okay, this part is also you can try. Okay, and first session, that first part, complete first part. That first part we have taken today's session, the complete that first part and then go for this. Yes. Okay, so we'll meet day after tomorrow, and tomorrow if anybody having doubt you can ask me. Okay, shall I stop here?
Yes.
Yes. Also.
Okay.
Okay then, bye, good night. Yeah,
Bye bye.
bye.